Hello all, and let's continue chapter 5, joint probability distribution. Okay, next, let's have a quick review. In the last video, we have seen the introduction and joint probability distribution. Joint probability distribution for two random variables. So we have taken one random variable in one axis and one random variable in another axis. We'll take f of x in one another axis. Okay, and we have two different types of joint probability distribution. One is mass function and another is density function. The mass function is all related to discrete random variables of x and y, and whereas density function is all about x and y continuous random variable. Here for random variable, discrete random variable, we'll calculate summation of f of x comma y, and total it will be 1. And whereas we are replacing summation with integration from minus infinity to plus infinity, and it will give 1 as sum. This is how it looks like when we draw both random variables and f of x-axis on one side and y-axis on one side, and one of f of x comma y on another axis. We have seen a problem. We have seen like integral, double integral minus infinity to plus infinity f of x comma y is equals to 1. And very important concept in marginal probability distribution for both the discrete and continuous. For discrete, it is simple. We are calculating the summation of x equals to 3, the probabilities of x equals to 3, and the individual value of x equals to 3 is 0.55. That is the marginal probability distribution in discrete function. Whereas for y equals to 3 is the summation of 0.02, 0.1, 0.005 is 0.17. So whereas for probability density function, marginal for continuous random variable, it is integral. Like if I wanted to calculate for x, marginal probability density function for x, we'll integrate f of x comma y with respect to y. So whereas we need x f of y, we will integrate f of x comma y with respect to x. So we have seen a big problem here, like in the problem, the probability that y exceeds 2000 milliseconds. So there is a one condition that we have splitted this 2000, about 2000 area into two halves. One is the x value less than 2000 and x value greater than 2000. We have calculated this problem, and mean and variance of joint distribution, it is very simple. And okay, mean and variance, it's like we have converted this table to two smaller tables, like x on y1 and f of x, y and f of y. So we can calculate directly e of x and v of y as we see in chapter 3. Next one is conditional probability distribution. The formula is same. For example, p of y given x equals to 3, the denominator x equals to 3 will be same for every denominator. P of x equals to 3, p of x equals to 3, x equals to 3, x equals to 1. Whereas in numerator, x is 3, x is 3, x is 3, x is 3 with different values of y. What are the possible values of y by taking a constant x? And conditional probability density function, same, like this is discrete and this is continuous. So simply we integrate it by like f of x comma y, f of x comma y. We know this function f of x comma y from the problem statement, whereas f of x, we don't know f of x. How we can calculate f of x? Simply we will integrate f of x comma y with respect to y. That is marginal the probability distribution. Okay, there is a problem, the same problem Determine the conditional probability density function for y given that x equals to x. So we need to find out f of x comma y divided by f of x, and probability y exceeds 2000, and given that x equals, so this is also conditional probability. Let's look into this problem. It will take some time since we need to integrate f of x comma y, and we will divide f of x comma y, integration of f of x comma y with f of x comma y, and we need to substitute. Okay, but the concept is same. So what is condition f of y given x, f of x comma y is equals to f of x comma y denominator f of x. So I have this function f of x comma y. So I do not have f of x. How we could find out f of x? When I integrate f of x comma y with respect to y, we'll calculate f of x. Okay, f of x. So what is we will we know this directly. I'm writing. Okay, with respect to dy, what are the limits for y? So one, we know this limit, y limit is starts with x up to infinity. So from x to infinity. So this is constant 6 into 10 power of minus 6. I will calculate only y function, not x. So e power of minus 0.001 is constant. So I'm taking it out. Since it doesn't have y, I'm not at all integrating this e power of function. So from x to infinity, e power of minus 0.002 y dy. 6 into 10 power of minus 6 into e power of minus 001x, e power of minus 002 y divided by minus 0.002 from x to infinity. So 6 into 10 power of minus 6 into 10 power, e power of minus 001x divided by 0.002 e power of minus 002x minus e power of minus infinity. So I think this is plus. So I'm just minus multiplied here. So after after calculating e power of these two, 0.003x, a power of m into a power of n, a power m plus n divided by plus 0.00. Finally, f of x comma x is 0.003, 0.003 or 2. It's 2 actually. So 2 e power of, sorry, 3. I'm just cancelling it out. 0.003 x. This is f of x. Now I know the denominator, I know the numerator. Simply substitute both. F of y given x is equals to f of x comma y divided by f of x. What is f of x comma y? 6 into 10 power of minus 6 e power of minus 0.001x minus 0.002y divided by 0.003 into 10 power of e power of 0.003x. So 0.002. And finally, 0.002 into e power of minus 0.001x minus 0.00 3x minus 0.002y. Finally, 0.002 e power of 0.002x minus 0.002y. This is our f of y given x function. This is problem A. Now problem B. What is the probability of y exceeds 2000 and given that x equals to 1500? So probability of y is greater than 2000 and x is equals to 1500. So I'm just integrating this function 0.02. Let me write. I need to find out the limits of y. He has given it exceeds 2000. Then it's from 2000 to up to infinity. So 2000 to up to infinity, 0.002 e power of 0.002x and minus 0.002y. So dy. So this is constant. Take it out 0.002. And one more thing I need to do here is substitute. Sorry, this is plus x value. What is x value? 1500. He has given in the problem minus 0.002 y dy. So this is constant. This value is constant. Take it out e power of 3 and integrate 0.002 y by 0.002 from 2000 to infinity. So substitute minus 0. Minus actually this is I think minus 4. Okay. This is minus, so minus upper limit, lower limit 0.002 2000 minus e power of minus infinity. So this is 0. How? E power of minus infinity is equals to 1 by e power of infinity. 1 by e power of infinity is infinity. 1 by infinity is 0. Okay. So this is 0. You'll get e power of 3 into e power of minus 4 minus 0. So e power of minus 1, that is the answer 0.367. The only challenge is calculation. Apart from the calculation, fifth unit is very easy. You only need what we need to substitute. In simply f of x, we need f of y with respect to y. We just need f of x comma y and f of x. We will get this value from the question and we need to integrate f of x comma y with respect to y to get f of x. That's it. The next concept is conditional mean and variance. So this is also quite simple if you know the formula. E of y x equals to x is integral y into f of with respect to y. So here this function, how we'll get f of x comma y, f of x, and this will give f of x comma y with respect to y. Everything is interlinked. We know f of x comma y, we'll substitute here. We don't know f of x, we'll integrate f of x comma y with respect to y. We'll get this value, f of y comma x, y given x. So multiply with y and putting y limits, we'll get mean value. Similar variance y of x equals to x equals to y limits y minus mu given x whole square f of y dy. Here also same question, same thing we'll get from here, and this is here. So directly substitute and we can another form is mu square y by x. This is another form of variance. Okay, while doing this problem, same type of problem, um, in textbook you can find same type of problem, same question with after this like C question is conditional mean. Conditional mean, if time permits now, I'm going to calculate this example condition with conditional mean. There you can find in middle integral of y e power of minus 0. Just I'm revising you. Might be you might forgot this formula. Like this is u v from I late. We will calculate u and v. First u and second is 0.00 v. We will differentiate this one. Differentiate this one. We will integrate this one. What is differentiation of y is 1. 1 differentiation is 0. What is integration? 0.002 y by 0.002. Again, this what is this integration? 0.002y divided by plus 0.00, like simply 0.4 into 10 power of 6. So multiply these cross terms, putting plus minus plus. So y into e power of minus 0.002y by minus 0.002 minus 1 into e power of minus 0.002y by 4 into 10 power of minus 6. This is the integration of this value. So I'm just recalling it. Next is independence. This is very important concept in exam point of view. Um, you might get these questions like what are the conditions for independency in joint probability distribution? Like we have multiple independency concepts. Independence. There are four conditions. Any one of the following condition, any one, not all, any one of the following conditions obeys, then x and y are independent. What are the other? What are the four conditions? One is f of x comma y is equals to f of x into f of y. So you can try at home. We have this function f of x comma y. Calculate this f of x. How? Integral f of x comma y with respect to y. Take some year example from 0 to 2000 or else 0 to infinity. This one integral to x comma y with respect to x. Take it as a limit 0 comma. If after multiplying both, if you get the same answer, both x and y are independent. Another one is f of x comma y is equals to f of y. So for all x comma y, and then f of x comma y of x. And finally, if probability of x belongs to A and probable y belongs to B, if probability of x belongs to A into probability of x belongs to B, these are the four conditions to find out whether x and y are independent or dependent. If one of these equations follows, then x and y are independent. I think I have a form. Okay, you can find a problem in my shared PDF in my handwriting notes. You can find a problem regarding this independency. Join PDF for more than two variables. This is complicated actually. So we have only one concept joint PDF for more than two variables. So far we have find out joint probability distribution with two random variables. Now it is three random variables. Similarly, there are two conditions f of x1 comma x2 comma x3 and so on up to xn, f of x comma n x2 x3 and so on xn is always greater than 0. When we integrate each and every term minus from minus infinity to plus infinity, f of x1 comma x2 x3 and so on x1 comma x2 x3 and so on xn, it will give summation is 1 with respect to dx1 dx2 and so on dxn is equals to 1. I think I mentioned a problem. Let's find out a problem. uh, Example problem. F of x1, x2, x3, x4. There are four different random variables. The function is 9 into 10 power of minus 2 e power 0.001x1 minus 0.002x2 0.0015x3 minus 0.003x4. So this is f of x. The question is what is the probability the device operates more than 1000 hours? Okay, this is the question. So P of x1 is greater than 1000, x2 greater than 1000, x3 is greater than 1000, and x4 greater than 1000. That means x1 starts from 1000 to infinity, whereas x2 starts from 1000 to infinity, x3 starts from 1000 to infinity, x4 starts from 1000 to infinity. Okay. Simply we will integrate all four random variables from 0 to infinity, sorry, 1000 to infinity, 1000 to infinity, and 1000 to infinity, and 9 into 10 power of minus 2 e power of 0.001 x1 minus 0.002 x2 minus 0.0015 x3 minus 0.003 x4 with respect to dx1, dx2, dx3, and dx4. Okay, just all are independent. So I mean, x1, x2 are constants when I integrate like if it is x1, I'm integrating x1, so I'll calculate this integration. Others are constants. Similarly, if I integrate x2, x2 will be we will integrate another x1, x3, and x4 will be constants. So finally, 9 into 10 power of minus 2. So this is 12. Sorry. 9 into 10 power of minus 12 e power of minus 001 x1 minus 0.002 x2 0.001 x3 minus 0.003 x4 whole divided by minus 0.001 minus 0.002 minus 0.00015 minus 0.003. So when we multiply this, it will get 9 into 10 power of minus 12. Substitute 1000 from 1000 to infinity, 1000 to x1, x2. So this is a 1000, this is 1000, 1000. Finally, I'll give e power of minus 1, minus 2, minus 1.5, minus 3, e power of minus 7.5, that is 0.00055. This is the answer for joint probability more than two variables. Okay. Next, covariance. First, covariance. What is variance? When it is a measure of a random variable, how it is varying with respect to f of x in one variable. Like in third and fourth chapter, we have only one random variable, we have only one variance. Whereas in chapter 5, we have two different variables. Random variable x has one variance, random variable y has another variance. When they combined, they will give one different kind of variance that is called covariance. It is a common measure of relationship between two random variables. Okay. Expected, like in covariance, expectation of h of x comma y will give summation h into x comma y, f of x comma y. When it is discrete, another one is integration. I think this is the only one and double summation x comma y, f of x comma y dx dy when it is continuous. Okay. What is covariance between x comma y? Sigma x comma y. This is the expectation, that is mean value. Sigma x comma y is equals to expectation of x minus mu x, y of minus mu x, you expectation of x comma y minus mu x mu y. Okay. Covariance is a measure of linear relationship between two random variables. Like it will give, the covariance will give whether it is linear or not. It will tells the relation. For example, x comma y. For example, the dotted lines are with respect to x comma y. It is look like it's linear, and it is above. It is going. The ratio is. I mean, the slope is positive. Then it is called positive covariance. Similarly, this is negative covariance. And for example, the values are like this with this is called zero, or else a block of values are set at one point. This is zero covariance. Okay. What is correlation? Covariance. We have seen covariance. Covariance is sigma x comma y. This is formula E of x comma y minus mu x mu y. What is correlation? Correlation is a factor. This is a factor. Denoted rho xy is covariance of x comma y divided by root of variance of x variance of y. Simply sigma xy by sigma x sigma y. This is covariance and this is standard deviation. Don't get confused. This is covariance of x comma y and this is standard deviation sigma. Generally, it is lies between minus 1 to plus 1. Okay. It is from minus 1 to plus 1. If x and y are independent, this is first condition. And second condition, if x and y are independent, then sigma x comma y and rho, this is very important condition, rho xy is equals to 0. This is very important. We should know about x and y are independent, sigma xy, I mean covariance and correlation, both are 0. It is useful to calculate whether it is positive or negative correlated. For example, this is positive covariance I have seen. This value will be rho is equals to plus 1. So plus symbol denotes positive. Carefully, please watch here. Plus symbol denotes it is rising, whereas 1 represents how many values are touching the line. If it's 0.5, for example, plus 0.5 means plus means positive and 0.5 means, for example, there are 1, 2, 3, 4, 5, 6 points, 7 points, or 8 points. There are 8 points. Out of 8 points, 4 points are on the same line, are on the regression line, whereas 4 are out of the line. So this is how we calculate this correlation helps you to find out whether it is on the line or off the line. Similarly, for example, rho xy is minus 1 means values are decreasing and all the values are lies on the line. 1 means, I think you understand this. And we'll very important concept, linear functions of random variable. You might see many problems regarding this concept, linear functions of random variable, but it is very quite easy. Like for example, he will give a function w is equals to 5x minus 2y. If expectation of w is this constant will comes out y 5, expectation of x minus 2 expectation of y. He will give what is E of x, E of y. Variance of w. Simply the constant should be squared. Phi square variance of x plus minus 2 square variance of y minus 2 into 5 into 2, 2ab covariance of x comma y. 25 variance of x plus 4 variance of y minus 5 to that and 20 covariance of x comma y. This concept is very important and very easy. It is like a square plus b square plus 2ab. Directly E expectation is quite simple, and you will take it the constant out, and directly you can expectation of x, expectation of y. Plus, minus means minus, plus means plus, whereas in variance minus 1 will be squared, so it will give positive value. For example, if x comma y is independent, it's straight away 0. We'll calculate 25 v of x plus. I think we have seen this problem in operation research class on Thursday, last class. Okay, I think that's all from my side. If you have any doubts, kindly email me, and that's it. Thank you so much.